microcontrollers. In this particular session, we are going to see the differences between the microprocessor and microcontroller and the criteria in selecting the microcontroller. Let us start with this, the differences between microprocessor and microcontroller. This is an overview of what an embedded system means, what a microcontroller is, right? So generally, so these are the basic differences between the microprocessor and microcontroller. The general purpose microprocessor, uh, the general purpose microprocessors contains no RAM. They'll not have any RAM. They'll not have read-only memory. If you take any Intel microprocessor, it will not come with built-in RAM, built-in ROM, built-in IO ports. You have to purchase them separately and interface them separately. Whereas microcontroller has a CPU, which is nothing but a processing section. And apart from that, it will come with finite amount of RAM, random access memory, read-only memory. And it comes with IO ports, input output ports, Timer is so in some microcontrollers, timers will be there. In some microcontrollers, timers will not be there. Right, ADC, analog to digital converter, digital to analog converter. So these are the all these things will be available inside that particular microcontroller apart from the processor. Okay, so these are the basic differences between the processor and controller. You can see in this particular block diagram. So CPU, central processing unit, it is interfaced to RAM, ROM, IO ports, timer, and serial communication ports. All these are connected to the CPU externally with the help of data bus as well as address bus. Address bus is used to identify the address of that particular device, and data bus is used to access the data from the device. And whereas in microcontroller you can see CPU, IO ports, RAM, ROM, timer, serial communication, all these things are given, are available inside one such a single block, which means all these are embedded inside that. They're already available inside that. Apart from processing section, RAM will be there, finite amount of ROM will be there, and IO ports will be there, timers will be there, and serial communication ports also will be there. So the general purpose microprocessor, we have to add RAM, ROM, IO ports, and timers externally to make them functional. So as I already have told you, we have to interface them externally to the processor. Whereas microcontroller, a fixed amount of on-chip ROM or RAM and number of IO ports makes them ideal for many applications in which cost and space are critical. In some cases, the requirement of application, in application, some amount of RAM is required, some amount of ROM is required, some amount of IO ports are required, but space will be very less. So if that is a requirement, instead of going with microprocessor, you can choose a microcontroller which will fit into your requirement. Okay, so in many applications, the space it takes, the power it consumes, and price per unit are much more critical considerations than the computing power. Processing power doesn't matter there, but all the remaining aspects are to be considered, are to be at maximum, right? An embedded product uses a microprocessor, microcontroller, do one task and only one task. So embedded processor means it is meant to do a particular work only, whereas a PC, in contrast with the embedded system, can be used for many number of applications. You can use you can use you can use that processor in processing the food, in processing in an application when processing the food, or in microwave oven, or else in the data processing area. So you can use the processor for many applications, but embedded processor is meant for only one application only. All right. So if you're using it in the application called as microwave oven, you can't use it for another application, right? So now coming to the next one, many applications are there with microcontrollers, home appliances, intercom, telephone, security systems, garage door openers. All those are the applications of the microcontroller. You take any application, you take the name of an electronic device that will have one or other microcontroller. In offices, we use telephones, mobile phones, computers, security systems, fax machines, microwave copier, laser printers, Xerox machines, color printers, paging devices. All these are applications of the microcontroller only. And automation industry, or else automobiles industry, trip computer, engine control, airbag, okay, and transmission control, like many other. Okay, many manufacturers. So these are the applications of the microcontroller. Okay.